Hey class, let's review Unit 1. So we started out Unit 1 with absolute value functions. So the general form of absolute value functions were y equals a absolute value of x minus h plus k. And so remember the a was the slope of the branches of the absolute value function. It also tells us the direction that it opens, and then it tells us if it will be wider or narrower. Wider if it's a vertical shrink, and more narrow if it's a vertical stretch. So this a value is 2/3, which means we know that it opens up, and since it's 2/3, I know it's going to be wider than the parent function with a value of 1. It means that it will have a vertical stretch. So it stretches it vertically, which makes it more narrow. The vertex is the HK part. Remember that the one inside the parentheses comes out as opposite, and the K stays the same. So you start at -1, -1. And then 2/3, so from that point up to the right 3, because it opens up, and then you can go up to the left 3 to make the other point. Since you can plug in any x value into this equation and get out a solution, the domain is all real numbers, so our x's are an element of the real numbers. And then the range are all the output values, which corresponds to the k value. That is usually our maximum or minimum value. In this case, it's a minimum value because all of the output values are above that. So your range is y greater than or equal to -1. All right, going backwards to write the equation then. So we need the general form again, a x minus h plus k. The a value is the slope, so I can find that by finding rise over run. Up 2/1 it looks like, so 2/1 reduces to just 2. It is positive again since it opens up. The vertex is at 2, -2, so I'm going to plug the vertex in for hk. So the equation will be y equals 2 absolute value of x minus 2, and then plus -2 at the end, or minus 2 again. Oh, I should mention this one has a vertical stretch. What did I say in the last one? Yeah, this is wrong. I'm sorry. This is actually a vertical shrink in the first one. I misspoke there because 2/3 is less than 1, and it is wider. This one has an a value of 2. See how it looks more narrow? This one is the stretch. Sorry about that. Okay, graphing a piecewise function. First, if I just ask you to evaluate the function for a given value, you look at the x inside, so f of -3. Then you look up at the function, you say, well, is -3 less than 0 or greater than or equal to 0? Since -3 is less than 0, you use the top function here, -x plus 1. So you're going to plug in the -3 into the top function, and that'd be -3 is +3 plus 1 would be 4. So the function evaluated at -3 is 4. How about for x equals 5? Then that, since 5 is greater than 0, we'd plug it into the bottom function. So 2 times 5 plus 1 would be 10 plus 1 is 11. So that's how you evaluate a piecewise function. To graph it, I used a table of values. So I said that this is how I would do it. We're going to graph y equals -x plus 1 if x is less than 0. And then we're going to graph y equals 2x plus 1 if x is greater than or equal to 0. I'm just going to make a table of values. Now the first value in your table should always be whatever this x value is for the domain. So we're going to start with 0 for both. Then for the left side here, I need x's that are less than 0, so -1 and -2. For the right side, you need x's that are greater than or equal to 0, so 0, +1, +2. Then you plug those in. So it's -x plus 1. So -0 plus 1 is just 1. -1 is +1 plus 1 is 2. -2 is +2 plus 1 is 3. Then since this x is just less than 0 on this side and is not equal to 0 for this particular function, the first point is going to be an open point on that line. So at 0, 1, we're going to have an open point, and then -1, 2, and then -2, 3. And it's going to go, oops, I graphed my first point wrong, sorry. 0, 1, open circle there, and it's going to go that way. All right, I can tell it's getting late when I'm recording this. I keep making small errors here. So plugging into this side is 2x plus 1, so 2 times 0, 0 plus 1 is 1. 2 times 1 plus 1 is 2 plus 1 is 3. Then 2 times 2 plus 1, 4 plus 1 is 5. This one, it is equal to, x is equal to 0 here, so this will be a closed circle at your first point at 0, 1. Since we already have a point at 0, 1, we're just going to put the other point right inside there, and then 1, 3, and then 2, 5. And there we are. Okay, this is a step function. And I know it's a step function because it doesn't have any x's. So these points are all just horizontal lines. So our first one is at -1 between -3 and -1. So these are the x coordinates. So that's like I have an x coordinate of -3, -1, and then the end one is -1, -1. Because when you plug in -3, you get out -1. That's what it's telling me. Except for that, it's not included at -1. So along the x, you go to -3. I'm going to zoom in a little bit. Go to -3 and down to -1, and it's a closed circle at -3, -1. Then go on the x to -1, then down to -1. It's an open circle there since this side is not equal to. Then the next one is at +1, so on the x-axis first I go to -1, and then on the y I go up to 1. So over to -1, then up to 1, it's a closed circle there because it's equal to 1. Then on the x I go over to +1, up to 1, it's an open circle, and then filling that in. And then we go from 1, on the x we go to 1 and then up to 3, and it's a closed circle. And then on the x, we go over to 3 and then up to 3, and it's an open circle. And then there's that step function. And the last thing we did in Unit 1 was write equations for piecewise functions. And so we have two lines here. They are defined by the domain, either to the one with the open circle that goes to the right. That one is for all x values that are greater than -1. And then the one that has a closed circle and goes to the left, that's for all the x values that are less than or equal to -1. Because the domain splits at -1. And then 1 goes to the right, so that's where the x's, along the x-axis get bigger, so greater than. And on the left, they get smaller, so less than. For each line, we will need to find the slope and y-intercept in order to write the equation for the line. So let's start on this side. I go down and right is -1. So -1 over 1. So a slope of -1 there. If I continue to draw that line with the slope, I can see that my y-intercept would be -2. So this side, I have an equation of -1x minus 2. On the other side, I have a slope of right up 1, right 3, so a positive slope of 1/3. And then, unfortunately, this looks like it's not, the y-intercept is not at a whole number. So I will need to do some algebra to find that y-intercept. So we start with y equals 1/3 x, and then plus b. You don't know what b is, but you can choose a point on the line. So how about the 2, 3 point that's labeled there, and plug in 2 for x and 3 for y. So 3 equals 1/3, and then 2 plus b. To multiply 1/3 times 2, you put the 2 over 1, and you multiply across. So it'd be 2/3, 2 times 1 and 1 times 3 plus b. And then subtract, because it's a positive 2/3, so we have to subtract that on both sides. So you can either say, well, 3 minus 2/3 is going to be 2 and 1/3 left. Or you can change 3 to 9/3 minus 2/3, and then that's 7/3. So either way, 2/3 or 7/3, 2 and 1/3 or 7/3. Typically we put it in the equation as an improper fraction. So I'd probably write it as 7/3. Then you're ready to write your final answer. So f of x equals, and you can use the square brackets, that's fine. We have this equation here, a -x minus 2. That's for if x is less than or equal to -1. Or we have 1/3 x plus 7/3 if x was greater than -1. And then that is our piecewise function. We'll do one more writing an equation for this graph, just because the writing is a little bit trickier, but remember this isn't graded and it's not mandatory. So if you want to see one more example, keep watching. Otherwise, you're good to go too. So this one splits at +1. We're going to the right, so x is greater than or equal to +1. And then to the left here, the open circle would be x would be less than +1. So let's find the slope and y-intercept for each of these. So for the left here, I got a slope of 1 up 1 over 3 again, but it doesn't cross. It doesn't look like it crosses at a whole number, so I'm going to need to solve for that. On the right side, I have up 1 to the right 1, so a positive slope of 1. So if I go continue that slope and connect the line to the y-intercept would be 0. So I'll just need to do the algebra for this side. Y equals 1/3 x plus b. Choosing an xy point. So I have -2, -2 is x and y. So plugging in -2 equals 1/3 times -2 plus b. So -2 over 1. So that's -2 equals -2/3 plus b. Adding 2/3 then, since it's negative, so add to both sides. -2 plus +2/3 would be -1 and 1/3, or with a common denominator, be -4/3, because -2/3 would be -4. Sorry, that's not right. -2 is -6/3, plus 2/3 would be -4/3. So that's what we get for b there. All right, final answer then. F of x equals, we'd have a 1/3 x minus 4/3 if x is less than 1, and an x just a 1x plus 0 if x is greater than or equal to 1. So you can have the 1 here at the x, or you don't need it, either one, because an x has a 1x in front of it. Okay, writing equation of absolute values and graphing. I think I'm going to skip those for now. If you want me to go through those with you, let me know. Thanks for watching.